tell you exactly how the program is going to go. First, Dr. Michaels will give his presentation for 15 minutes, and then Mark Tabbert will do his presentation for 15 minutes. And then there will be a rebuttal from Dr. Michaels. Excuse me, I think this was printed incorrectly. John Hoaglung is also going to give a 15-minute presentation. And then there will be a rebuttal from Dr. Michaels, a rebuttal from John Hoaglung, and then we're going to have an informal conversation between Dr. Michaels and Greg Diamond for about 20 to 30 minutes, and then we'll do a question and answer session, and then we'll close. So without much more ado, I will introduce you to Dr. Patrick Michaels.
Good evening. I always love speaking about climate change. I was a professor at University of Virginia for 30 years, and in my class on global warming and the greenhouse effect, on the first day, I would challenge students to name a subject area and to see if I could not connect it to the issue of climate change, and they rarely stumped me on it. So, this is me. I run something called the Center for the Study of Science at the Cato Institute. I'm a PhD atmospheric scientist from the University of Wisconsin, Madison in 1979. And I would like to talk to you about the issue of climate change, I think, in a way to clarify what we know and what we don't know, and let you think about what you really want to do about it. I'll go over some of the options as to what we can do and what these policy choices would do. So let's start off with the beginning, okay? I really object to the notion that people either are alarmists on global warming or they are so-called deniers. Denier, of course, being a very loaded word that a few words later usually comes up with the word Holocaust. This is a surface temperature record from the University of East Anglia in the United Kingdom. It's the record that scientists tend to use the most. And you can see there are actually two warmings that occurred since this record starts late in the 19th century. It gets to be somewhat trustworthy around here. There are problems with these surface temperature records that are pretty severe. But this warming here is of the same magnitude as this warming here. This one from 1910 to about 1945 could not have had anything to do with human influence with regard to the greenhouse effect because we hadn't put in enough carbon dioxide in the air to accomplish that. If this were caused by carbon dioxide, these temperatures would be up on the second floor right now, and we wouldn't be chatting so amiably about this. And here is the problem writ large. There are 102 climate models used by the United Nations that synthesize temperatures not only on the surface, but in the upper atmosphere as we go up from the surface into the stratosphere. And here are two sets of temperature data. This is 1979, when the satellite that takes temperatures first began returning data. The blue circles are 4 different records from weather balloons that are launched simultaneously around the world, and they take the temperature with calibrated instrumentation. Taking the temperature, as anybody who has a weather station knows, is not so easy. You have problems with sun, you have problems with the surrounding environment. But in the layer from 5,000 to 30,000 feet, where these temperatures are from, there are no cities. We don't have to worry about confounding the temperature record. The green squares are the 2 satellite data sets, one from the University of Alabama, the other one from Remote Sensing Systems in Santa Rosa, California. They are the only 2 of the large-scale data sets. And the red line is the forecast. The climate models that the United Nations use have the luxury of putting in 2 volcanoes. This is the Pinatubo volcano in 1983. El Chichon in 1983. This is Pinatubo in 1992, I believe. So they have the luxury of having that to cool them down. Then they bounce back up, and they predict this large warming, and the difference between what is being predicted and what's being observed is profound. Most scientists, if this were not a highly charged issue, would hold up their hands and say, how did this happen? And they would say, because we spent $3 billion a year on this per year, just the United States, on global change research. Most scientists should hold up their hands when they say this to the question, what happened? and utter the three most important words in life, which are not "I love you," they are "we don't know." And then there's the infamous pause. My friends who like to say, and there are certain congressmen, certain people in Washington who will say there's no such thing as global warming because it hasn't warmed in the surface temperature record for 18 years. This is the East Anglia temperature record, and let's see if that really wrecks the notion that there is such a thing as human-induced warming from carbon dioxide. This is, by the way, the satellite record. The satellite record actually is now in its 22nd year. No, it'll get into its 22nd consecutive year without a significant warming trend, beginning in November of this year. That certainly was not forecast to happen, and it should give it pause to anybody about saying that we know enough to spend a lot of money. So I'm going to show you, though, that the people who say that that invalidates the whole greenhouse warming issue, that does not support it. So I'm going to give you a little bit of basic global warming science, very, very basic, very, very simple. The response to temperature to putting in carbon dioxide, whoa, I went over too, is what we call a logarithm. So as the carbon dioxide concentration in the atmosphere goes up, the amount of warming that you get for a given change in carbon dioxide becomes less and less. It never stops increasing the warming, it just begins to damp off. Now, this is no great revelation, okay? This was first noted by John Tyndall in 1879. It's not like this is rocket science, and you can do it in a laboratory with an infrared spectrometer, and you can see for yourself. Now, the CO2 that we're putting in the air goes up as a low-order exponent. It has to do with economic growth, population growth, all kinds of things. Chinese growth, China's emissions about 10 years ago were roughly 20 or 30% below ours. Now they're twice ours. In 1 decade, they've gone up that much, and they're going to go up a lot more. But in pre-calculus, you find that if you add a low-order exponent and a logarithmic curve, the response function oftentimes looks very much like a straight line. And there's factor number one that a lot of people don't appreciate about climate change and climate change models. They don't predict increasing rates of warming. They predict constant rates of warming. So that means anybody who says, the planet is warming at an increasing rate is saying the computer models would be wrong. No, the models predict a constant rate of warming. If you don't believe that, take a look at this suite of models. This is from the 2007 IPCC report. There's just not an analogous illustration in the new one, so I have to take that one. Each piece of colored spaghetti is a climate model. This is the year 2000. This is the year 2100. The solid dots are the average of all the climate models. That looks pretty much like a straight line. So, obviously, the cynics would say, well, the pause, they can't have the pause and have this happen. See, there's the pause, so that invalidates the straight line warming of the models. Well, why don't we take a look and see what really happened, beginning with the second warming of the 20th century, which began around 1976. I showed you that in my first graph. People think that probably is the initiation of some type of human signal in the warming trend. And let's see how well that straight line fits the data, despite the fact that there's this pause. Whoop, and there it is. Oh my God. This is the pause period here, but this is the straight line function. So yeah, we're not quite as stupid as we look as scientists. We actually got the mathematical form of it right, that once it starts, it would take place at a constant rate from a mathematical sense. But the problem is not that. The problem is not whether it warms, but how much it warms. And let me, some of you have spent time in the eastern United States in the summer, and you know that, therefore, how glad I am to be out of the stinking swamp of Washington, D.C. for a few days in August. It's horrific. And so what people are taught, the weather proverb in the eastern United States is, it's not the heat, it's the humidity. Well, in climate change, it's not the heat, it's the sensitivity. It is going to warm up. If you put carbon dioxide in the air, the lower atmosphere will warm. The stratosphere, beginning about 50,000 feet over our heads, will cool. The overall system temperature doesn't change because the same amount of energy is hitting it, but the distribution of heat changes. So you will get surface warming. So the question is not whether it will warm, but what is the sensitivity? The sensitivity has a definition. It's defined as the amount of warming you get for doubling atmospheric carbon dioxide. Well, you know, Mikhail Gorbachev once had a great put-down phrase for people he didn't agree with. He would say, "Oh, that's old thinking." Well, I'm showing you old thinking right here. This is what goes into the federal government's calculation as to what they call the social cost of carbon. When the Obama administration says that, you know, this regulation is going to save umpty-squat billion dollars that we don't have, it's based upon an assumed cost, social cost, imposed by those carbon dioxide emissions. And those costs are generated by these probability functions for various amounts of warming. And these are generally the median warmings predicted by these various and sundry models. But notice this is called a fat tail. And the probabilities of 5 and 6 degree warmings, sensitivities, warmings for doubling of CO2, are not vanishingly small. That is the core of the policy activists' argument. We can't afford to go on when these curves have such fat tails. I fear fat tails. People fear fat tails. And let's see what's happened as research has evolved since this study, which was came out getting pretty close. These came out close to about 10 years ago now. By the way, this is what the government uses for its probability functions for warming. There are 95% probabilities from 1.5 degrees Celsius sensitivity all the way up to pushing 7 degrees Celsius. That's a huge number. Now let's see what's happened in the last few years. Here are the recent estimates of sensitivity for papers published since 2011. Here's what the government used. Here are the values reported in 50 separate experiments by about 50 researchers from, I think, 12 countries around the world. What we're seeing is the sensitivity of temperature to carbon dioxide is not nearly as much as we thought it was. Now, I really wish I could walk here, and will the videographers be angry if I move and speak loudly or not? Okay, hey, great. The problem is, it's been known since 1987 that computer models left to their own devices predict far too much warming for doubling atmospheric carbon dioxide, and so that they are fed another competing emission called sulfate aerosol. Sulfate aerosol is fine dust. It reflects away solar radiation. It results in a compensatory cooling for carbon dioxide. But we don't know how much it is. So that's why you can fit the past perfectly with a computer model, because you can put whatever number you want in for the compensatory cooling, and the model doesn't run away with warming. Well, recent research has finally narrowed down the ranges of the compensatory cooling, and it yields a remarkable result.
You have 3 minutes.
Thank you. Yields a remarkable result, you don't have to tell me anymore, which is the median sensitivity is now around 1.2 or 1.3 degrees, and the fat tail is gone. So, what's the conclusion? Well, first of all, it looks like the computer models are not working very well. This is the average warming rate for the last 10 years, 11 years, last 60 years, predicted by all the United Nations computer models. These are the 95% confidence limits, and these are the observed values. Where the observed values turn from green to yellow, the observed values fall below the 95% confidence limits in the models. The model statistics, where they are red, they fall below the 97.5. 3 most important words in life. We were wrong. That was presented at the American Geophysical Union in San Francisco last December. Now, I'm going to finish with something very important. The notion of opportunity cost. How much bang do we get for the policy buck? So I am going to run a model here, the EPA's own model for the estimate the impacts of policy choices on global atmospheric temperature. The model is called the Model for the Assessment of Greenhouse Gas-Induced Climate Change. And if you're listening, and I'm not making it up, the acronym that describes that model is MAGIC, Model for the Assessment of Greenhouse Gas-Induced Climate Change. The model assumes a 3-degree sensitivity of temperature to carbon dioxide. And the model calculates that if we just go on as business as usual, the temperature will rise 2.62 degrees globally between 2000 and the year 2100. You can also tell the model, reduce the United States emissions, not California's emissions, the United States emissions to 0 today, and keep them there until the year 2100.